A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to the session of geography, where we shall be continuing with the portion of the final portions of geomorphology. Now, yesterday we had been discussing about the portions of mass movement in slightly greater detail. We discussed about the stages of river movement, and then we have been discussing about the different types of erosional and depositional landforms created as a result of river action, where we saw one basic fact that as and when the speed of any of the agent of nature is higher, its carrying capacity increases. And when the speed is higher, erosion is one of the predominant actions that you will observe. And when the speed slows down, when the speed is slower, deposition is one of the actions which tends to predominate. Now, here, today, we shall be discussing the various other different landforms developed underground by the action of, let's suppose, the glacial movement, by the action of the wind movement, and by the action of the sea waves. So these are the different landforms that we are going to discuss today. All of them have got the same kind of a principle, where when the speed is high, there will be erosion. Due to the force imposed by these agents of nature, there will be erosion and erosional landforms will be created. Whenever the speed is slow, there shall be a series of various different depositional landforms which shall get created. So we start first of all with the landforms developed underground with the help of water. So here, in the portion directly underneath the land surface, don't think about that in the lower portion of the crust in the mantle, no. Directly, almost directly underneath the land surface, oftentimes there are large cavities, caves, and various erosional and depositional landforms which are created as a result of the chemical property and the chemical reaction induced by water and the movement of water. Now, this series of landforms, they are also known by the name of karst topography. This is what is also known as karst topography. Karst because of the region in the erstwhile Yugoslavia, where for the first time this kind of landform was found, that karst region in Yugoslavia. Okay, so that is the karst topography. Now, here you will observe that water, by its property that it can form a solution, it tends to react with those particular materials or those rocks which are soluble in water. So these kind of landforms will only be formed in those areas where the rocks are primarily made up of the materials which are soluble in water. For example, limestone rocks. Limestone consists of calcium. Calcium is soluble in water. So in limestone rocks, oftentimes you will come across very large cavities and structures created. So here, when we talk about it, basically created in areas where the rocks are made up of materials soluble in water. Okay, where the rocks are made up of materials which are soluble in water, which can be dissolved in water. Now here, ideally what happens when you have, let's suppose, rainfall falling upon an area, or maybe a stream flow also. Now, when they encounter rocks such as limestone, which consists of calcium being soluble in water, they start dissolving those. Slowly and steadily, they will start dissolving those, and they will start creating cavity-like structures. They will start eating them up, and eventually, cave-like structures can be created. So here, basically, you will observe that in this case, chemical solution or erosion of rocks like limestone is observed. Okay, that is the scenario in this case. Now, this creates a series of erosional and depositional landforms. Erosional landforms, for example, sinkholes as well as caves. Depositional landforms such as stalactites and stalagmites. So, when we say erosional landforms here, sinkholes, what are sinkholes? So, let's suppose you have here, let's suppose here, you have a large rock surface which has the presence of limestone rocks. Now, if there is regular rainfall, okay, now this water will slowly and steadily start dissolving the rock material. Slowly and steadily, these will start dissolving the rock materials. Okay. They will start dissolving the rocky materials here. Now, eventually, what will happen in this case? As they dissolve the materials here, the structure will weaken. And when the structure weakens, the entire area might develop a large cavity-like structure. The entire area might develop a cavity, and that is what is a sinkhole. So here, observe this. This is what is a sinkhole. Okay? What we see here, that is a sinkhole. Now, don't confuse it with the portion that we studied as potholes. There, the size is very small. These sinkholes are very, very large in size. Each of these sinkholes can be many, many meters in diameter here. So, for example, here you observe these pathways. They indicate a full-blown highway or a road network here. So that tells you how big these sinkholes can become. Now, eventually, after a point of time, observe here also. So, because it is a limestone rock bed, which is soluble in water easily, so that is when the water over a period of time has been dissolving these materials. Now, it might happen that over a period of time, this becomes a continuous structure. This becomes a kind of a continuous structure, a continuous whole. Because even the material here, they also might get dissolved. Even the materials here, they also might get dissolved. So in that case, they end up creating, when a lot of these sinkholes they get together, they end up creating what are known as valley sinks. Multiple sinkholes getting together creates a valley sink. Now, this valley sink is what is known as an uvala. So that is what the sinkhole basically creates. Okay. So here, if you take a look at the schematics, you will observe initially as the water starts percolating in an area, just as I told you earlier here also, that as the water percolates, it forms multiple different channels, weakens that region, and eventually you have a sinkhole getting created. This is how the sinkholes get created. Much larger in size. Potholes, they are very small, few centimeters in diameter. Sinkholes are multiple meters, tens and twenties, and even 100 meters in diameter, their size can be. So that is where the sinkholes are much larger. Now, oftentimes these sinkholes can get together and they form what are known as the valley sinks. That is what we know as the valley sink. Okay. So that is the case of an erosional landform. Another erosional landform created is a cave. Now, underground caves are very prominent in these limestone rock areas. You'll find a lot of underground caves or large cave network within the mountains and the hill systems. You will find large network of interconnected caves. So here, when we talk about the cave section, you will observe here in this case. So it might happen that rainwater has entered through this area. Okay. And rainwater, as it has entered through this area, it has dissolved the portion of limestone or calcium or whatever is there. And it has created a large cavity. Slowly and steadily, the water will find its exit path. Okay. Slowly and steadily, it will find an exit path. So that is how you have large underground caves and cave networks created. For example, in Cherrapunji Mawsynram, even in Karnataka, the Yana caves in Karnataka, then in the region of Meghalaya, in the area of Cherrapunji Mawsynram, you have large amount of these underground and caves networks which exist. And in the hills of Cherrapunji Mawsynram, you'll find a lot of such cavities through which, once you enter, you have a pathway of interconnected cave networks, pathway of interconnected cavities, all these caves leading to each other. And that is basically because the limestone, rich in calcium, has been dissolved there. So, caves are also erosional structures which are created. Okay. Now, then when we talk about the depositional structures, so basically, this property, chemical property of water to form solution, that also leads behind depositional structures. Now, depositional structures left behind by this is based on a simple property. And the property is, when water is in a solution, when water is in solution, and if it evaporates, the dissolved material salts are left behind. I hope we would be aware of this reality and this fact that when you have a solution, solution of, let's suppose water with salt, let's suppose that is the solution. Now, in that case, when you have water with salt and that salt is dissolved in water, let's suppose the water evaporates. Now, when that water evaporates, the salt gets left behind, right? That is always the case. If you have not seen that or observed that till now, do verify it or observe it. So whenever you have a solution and then water, if it evaporates, it leaves behind the salts. Now, when you have, let's suppose, due to rainfall or other conditions, here, now due to rainfall, etc., now basically water will start coming down and seeping down this area through the rocks. As the water seeps down through the rocks, something basically what happens is that the water will start carrying all the calcium materials, etc. Let's suppose this is a large cave-like network. Now here, the water has started seeping down. This is the surface, land surface. So here basically the water has started seeping down. It has dissolved all the calcium that it can, or all the various other elements that it can. Now here, let's suppose there's a droplet which is created. Okay, it is not as if the water will start seeping like a tap. It will form a small droplet. It will hang from the ceiling of the cave. It will keep on hanging. Its size will increase and then that droplet will fall. That is what happens. Even in cases where you have seeping roofs during the rainy season, you would have observed this. This is something which happens. But let's suppose water evaporates from this position itself. When the water will evaporate, it will leave behind the calcium. When the water will evaporate, it will leave behind the calcium. Okay, so that calcium will be solidified, and calcium being sticky in nature, it will cement itself to the roof of the cave. Okay, then after some time, again, let's suppose another droplet of water develops. And that droplet of water, let's suppose, develops here. Okay, now it can fall to the ground surface or it might evaporate. If it evaporates, it will again leave behind the calcium that had dissolved in it. It will stick to the earlier structure. Like this, the repeated property of this ends up creating an icicle hanging structure almost, which hangs from the ceiling of the cave. And these overhanging structures, these are what are known as stalactites. These are what are known as stalactites. Now, sometimes what can also happen, let's suppose water from here drops. It drops, and it falls on the ground. Let's suppose it falls on the ground, it keeps on accumulating, it can form an underground small pool also, right? In many of the images, visuals, wallpapers, etc., you would have seen that inside the cave there is a kind of a small pool of water which is created. So that can also happen. But here it falls. Let's suppose this water from here then evaporates. From the base itself, the water evaporates. So as the water will evaporate, it will leave behind the calcium. Okay? Because when the water evaporates, it leaves behind that salt in the own place. Let's suppose another drop falls on it. Again, if water evaporates, it will leave behind the calcium. Here again. Again, let's suppose water falls and evaporates. Again, it will leave behind the calcium. Again, let's suppose the water falls and evaporates. It will again leave behind the calcium. So like that, you have deposits of such calcium-like structures which stand up from the ground surface. That is what is known as stalagmites. These are stalagmites. Okay, so how are stalactites created? So when the water starts falling from the roof, in your own, not in your own house, let's suppose in some other older government buildings or offices or your older school, you would have seen that when water starts seeping from the ceiling during the rainy season, it is not as if it starts to flow like a waterfall. It falls drop by drop by drop. Slowly and steadily is how the water falls. Now, every time that the water will fall, it will form a bulging drop. That drop will be suspended from the ceiling. It will be overhanging from the ceiling. And that drop, basically, when it is overhanging from the ceiling, it will tend to become heavier and heavier and heavier till it becomes large enough, it will fall on the ground. You would have experienced this in your life sometime or the other. Now, imagine a scenario where that droplet, many of the times, it remains on the top of the ceiling itself. It is hanging from the top of the ceiling. It never becomes large enough, but it evaporates. So, when it evaporates, it will leave behind whatever materials it had dissolved. Right, that is why in the older houses and older roof structures where seepage is very common, you will observe that there you have slight protrusions from the ceiling, very slight small protrusions hanging upside down from the ceiling, very, very tiny protrusions. That is basically the calcium of the paint and the cement that rainwater had dissolved and the rainwater has evaporated now, leaving behind those deposits in the form of protrusions. So here what happens is that, let's suppose this water, it starts to fall. It can fall from the roof of the ceiling, but slowly and steadily it will grow larger. Let's suppose it grows larger, it doesn't fall, it evaporates. It will form slight protrusion of calcium that it had dissolved. Let's suppose again that process is repeated. So that mound of calcium overhanging from the ceiling, that will grow larger and larger and larger. Now calcium has got the binding property like cement. Cement uses calcium. So calcium has got binding property. So that calcium will stick with each other. That is when the entire overhanging structure will stick with each other. And that is when you have these overhanging structures on the roof. And that is what is referred to as stalactites. So that is basically the stalactites. And on the ground surface, when you have the drops which fall on the ground surface, let's suppose they evaporate from the ground surface, then they will leave behind that calcium, and that is when they will solidify. That calcium will solidify upon multiple repetitions and reiterations of the process, and you have the stalagmites. Sometimes what might happen is basically the stalactites and stalagmites, they can get together. Let's suppose you had a stalactite and a stalagmite. they can get together. When they get together, they form a pillar or a column-like structure. Pillar or column-like structure. Okay. So these underground landforms, they are very prominently found in those areas of higher rainfall, so that availability of water seeping through the ground is maintained, and also in those areas where you have limestone rock beds, Yana caves in Karnataka, then the region of Cherrapunji Mosinram in Meghalaya, that is the Shillong and the Karbi Anglong plateau of Meghalaya. These are the areas where you can have these landforms which will be very, very dominant. Okay, so that is basically the case of the stalactites, stalagmites, as well as the columns and the pillars. Okay. Now we come to the landforms which are developed by glaciers. So when we talk about landforms developed by glaciers, here glaciers are massive, very massive forces of nature. The amount of force that the glaciers impose is quite high. Now, these glaciers impose a weight on the ground, and they will always be moving slowly under the influence of gravity. Right? Now, all these thick, many meters of ice, that thick ice, don't compare it to the ice that you see in your refrigerator. And don't think about it that this ice is so light. What he's talking about, the glaciers. Glaciers are very, very heavy. They impose thousands of tons of weight on the rocks, and they will slowly and steadily rub against the rocks, grind against the rocks. So small particles of that rock structure will be shaved away by these glaciers. And eventually, what will happen is that these glaciers will erode away, will rub away the entire portion of the rocks. And that is how it forms the erosional landforms. Now, as the glacier moves beyond a particular point, it will start melting. As it reaches closer to the sea level, it starts melting due to higher temperature. That is when all the materials that it had carried will be deposited by the glaciers. But the glaciers, in itself, in terms of where they flow, the glaciers can be classified into two types. What is known as the continental glacier continental glacier and then alpine glacier. Now, alpine glaciers are the ones which are found in the mountainous areas. For example, in the Himalayas, in the Alps, in those ranges, the glacier flow which is observed in those areas, that comes into the category of alpine glaciers. So found in mountains. And glacial ice formation is attributed to low temperatures, very low temperatures at greater height. Now you also have what is known as a continental glacier. Now a continental glacier is the one which moves across the plain areas also, generally found in the region, for example, around Antarctica, around the region of Greenland, and during the ice ages, even in the region of northern Western Europe, northern Asia, northern portion of North America. So in those areas, so during the ice ages, that is where it would basically move. So moving across plain areas of higher latitudes or regions frozen during ice age. That is when the glacier is in motion. That is when you observe that glacier in existence. Now, here again, the same principle is followed, that carrying capacity is always proportional to the speed. If the speed of the glacial movement is high, it will be able to carry a lot of materials along with it. If the speed is slow, that is when it will start deposition rather than carrying stuff with it. So here again, the same thing will be observed, that is carrying capacity is proportional to speed. Okay. Now, when we take a look at the series of erosional landforms here, one by one we'll take a look at it. But before that, just an overview of the glaciers. So here, observe this glacier. What you observe here, this is actually a glacier. This is a glacier in the region around the Everest base camp. Okay, this is what is also one of the most treacherous paths in your summit to Mount Everest. This is what is regarded as the Khumbu ice fall. So this is where you have the movement of ice taking place slowly and steadily, the movement of ice taking place. Now, from the ground surface or from the view here, it might appear as if you have snow or ice which is moving. But a zoomed up image of this Khumbu ice fall, if you observe, this is what it looks like. Observe each one of them. Now, this is just for your point of reference. This is the size of a fully grown adult individual. So, all these glacial ice, you can imagine that glacial ice is rubbing against the ground surface and then is moving against it, right? And in between this glacial ice, you have large cracks, crevices, 3-story, 4-story deep. If you get stuck there, you're stuck basically forever. So these glaciers move very, very slowly under the influence of gravity. But as they move under the influence of gravity, they will impose the weight on the ground surface, on the rock surface, which will erode the rock surface from above. So here, glaciers are massive bodies or slowly moving ice. They form over land and are made up of fallen snow that gets compressed into ice over a period of centuries. Right? So the snow gets compressed, and hard ice is created. They move slowly downwards due to the pull of gravity. So this is basically the glacial here. Observe here. This is your glacial movement. So it will move ever so slowly. But again, don't mistake it to be a small snow movement. This is full-fledged movement of ice that you are able to observe. Okay. Now here, whenever and wherever the speed will be slow, they will start depositing the materials they have eroded from the rocks. Slowly and steadily, they will start depositing the material. So here, observe the deposits. There are some deposits here in these areas. You have the deposits in these areas. You have the deposits in these areas as well. You have the deposits in these areas as well. You have the deposits in these areas as well. Right. So such kind of fine particle deposits are always created by the glacial movement. These fine particle deposits, these are what we know as moraines. So these are what you refer to as, these are the deposits here. These are known as moraines. Now these moraines, they are named dependent upon where they are deposited. For example, here these deposits, along with these materials here, these are on the sides of the glacier. So they are also what are known as lateral moraines. Lateral moraines, because they are deposited on the sides. Now, moraines, they are when they are deposited in between here. Let's suppose these regions. Now, here they are known as medial moraines. So whenever their speed will reduce, they will start depositing. So these are, moraines are basically deposits of fine particles created by glaciers in the regions where the speed of glacial ice movement is slow. Is very less. Okay, so where the speed of the glacial ice movement is very, very less, that is where you will observe these deposits. So if deposits happen on the sides of glacier, lateral moraines. Lateral, I hope we know the English meaning of lateral, on the sides. So lateral moraines. If deposits happen in between the pathway, happen in between the pathway, that is medial moraine. If let's suppose these deposits happen at the end where the glacier starts to melt, that is when it is the terminal moraine or the end moraine. If deposits are created at the end of glacier, that is terminal moraine or end moraine. Okay, so that is how these glaciers, they can create deposits also. Because observe here, in this case of Khumbu icefall also, if you will observe, there are some deposits which are here, which are solidified over a period of time into rocks. But observe here, there are deposits here also. Okay, so wherever the glacial ice, its movement slows down, that is when it will create these deposits. Okay, so that is basically the case of the glacial movement. Now, let us take a look at few of the erosional structures created by glaciers. So one of the erosional structures created by glacier is a cirque. Now, when we talk about a cirque, it is an erosional landform where you observe. For example, observe this image. Here, at one point of time, you can imagine that in this entirety of the area, in this entirety of the region, the glaciers would be moving in this area at one point of time. Now, obviously, you don't have glaciers moving there anymore, but there is a scooped out amphitheater like depression created in the mountain. So, here, don't worry, the SME has been requested here to answer the questions as soon as possible. Okay, so here, basically, you will observe that there is a significant amount of cavity like portion which is created. Significant portion of depression created. So a glacier at this point of time, at one point of time, might have existed in this region and has carved out an amphitheater like depression in this entirety of the area. So here, these are amphitheater like cavity carved out from the sides of the mountains due to glacial erosion. Now here, this is the erosion that you are observing from one side. So it is easy to imagine that at one point of time, the glacier would have moved from here and would have drained in this area. Now the glacier is no longer in existence there. The glacier has basically melted out in this area. So that is why you observe this. But here, basically, that would have been the situation where the glacier would have been originating here and would have moved down the slope of the mountain. Now, here what you observe is a small lake-like structure. This is formed because of the glacial melt, the melt water because of the glacial water. This is also what is referred to as glacial lake. That is what is known as the glacial lake. Okay, so that glacial lake basically is when you have water which is accumulated over these small lake like portions, water that is accumulated, that is what is a glacial lake. Okay, so sometimes what happens is, let's suppose there is in the Himalayas also, you will find many of these glacial lakes. So sometimes what happens, let's suppose that there is an earthquake or there is a massive landslide in this area. Now, all of this will basically, the materials will immediately get dumped into the lake. So, what will happen to the water? If this lake is large, what will happen to the water? That water will overflow, isn't it? That water will overflow. Now, this is a small lake, but these lakes can also be very large. In the Himalayan mountains, these lakes can be very, very large. So, that is when you have the phenomena which is known as the glacial lake outburst flood. What has been experienced in Sikkim recently, Uttarakhand previously. So it is in these lakes that you observe the phenomena of GLOF. Glacial lake outburst flood is a phenomena which is observed in these areas. Okay, so again, cirques, how are they created? As the glacier would have moved in this area at one point of time, it would have scooped out the mountain sides, eroded the mountain sides, and that is how you have a kind of an amphitheater like eroded structure which is created. That is a cirque. Now imagine if this mountain would have had glacial movement on both sides. We are seeing the glacial movement only on one side. Imagine if the glacial movement would have happened on the other side also. So on the other side also there would have been erosion. So the mountain basically would be left behind as a thin, narrow ridge-like structure. So the glacier would have eroded from here also, here also. So if the glacial movement would have happened from both sides, erosion would have happened from both sides, a very thin, narrow ridge-like structure would be left behind. And this thin, narrow like structure, ridge like structure, this is what is known as an arête. When mountains get eroded, here by mountains we mean the large series of these mountains and ranges get eroded, from both sides, leaving behind a narrow ridge-like structure. Now imagine if the erosion would have happened from all the sides. Here, in the case of a cirque, what is this? In the case of a cirque, you have the erosion happening only from one side, isn't it? Now imagine if erosion happened from both sides, you have an arête. If erosion happened from all sides, in that case, you are left with a very thin standing structure, isolated standing hill rock like structure. This is what is a horn. So when we talk about horn, these are isolated features left behind as glaciers erode the mountains from all sides. That is what we regard as a horn. Okay, so that is the case of basically cirques, arêtes, and horns, which are created due to erosional structure and erosional processes observed in the case of a glacier. Now, there is also another erosional structure generally observed in the coastal areas, and that too in the region around New Zealand, in the region around Norway, Canada, Sweden, Finland, and these are valleys or the glacial valleys at one point of time. These are known as fjords. It is not fjords, it is fjords. So, what are these fjords? So, fjords basically are the glacial valleys which have been created due to the action of the glacier at one point of time during the ice age, when the entirety of the region would be covered under ice and massive ice movements. At those times, the glaciers basically would have carved out these valleys. So, a fjord is a long, deep, narrow body of water that reaches far inland. Glaciation basically carves deep valleys. This is why fjords can be thousands of meters deep as well. And they are usually deepest inland where the glacier would have initially moved. Okay, so basically, what it means, let's suppose this is the landmass. Let's suppose this is the landmass. Just as an example, I'm giving you. Let's suppose this is your sea, this is your land, this is your sea from all sides. Now, at one point of time, in the older days, maybe thousands of years ago, there would have been the entire region would be covered under ice. We can assume that. Now, glaciers would have moved from here, and the glaciers would basically would have, let's suppose, moved from here. They would have moved from here. They would have moved from here, here, in all these areas. Now, as these glaciers would have moved from between the mountainous regions, they would have carved out deep valley like depressions. Very deep valley like depressions would be carved out. Okay. And the glacial ice would be moving here. Now, over a period of hundreds and thousands of years, this glacial ice, obviously, as the ice age would have ended, the glacial ice would also have melted out. As the ice age would have ended, all this glacial ice would have melted. And in its place, because it is a deep carved out valley, as the glacial ice would have melted, sea water would have entered in this area. And this region would be filled with saline, salty water now. As sea water would have entered these valleys, you would have these kind of formations. Even today, if you look at the coastline of Norway, you will observe that the coastline is not straight, like what you observe in the coastline of India. For many of us, we don't even know where Norway is. What is the capital of Norway? And panic struck the masses as if it was a pandemic. Okay, so the best answer is that the capital of Norway is Sweden. What is the capital of Sweden? Norway. And the capital of Norway is Sweden. And both of them, they share the capital, that is Finland. How can you say capital of Norway is Sweden, my dear friend? Okay, so I have Finland also, Tel Aviv also. Good. Capital of Sweden? Thank you. See, these are the basic things, guys. I hope you have not joined the geography sessions here so that you get an idea about the countries and capital. If we go back to that level of basics, that okay, this is India, capital New Delhi, this is China, capital Beijing. I hope we are not reduced to that level. Anyways, locate Norway on the map, observe where Norway is, look at the capital. So, I was telling you that you would have observed the coastline of Norway, but right now the priority is observe where Norway is. Then observe the coastline of Norway. You will observe that the coastline of Norway is highly indented with these kind of things. Okay? The coastline is highly and heavily indented with these narrow outlets. Now, whosoever is telling Oslo, I won't take the answer anymore. In this point of time, I could have called somebody from Norway and got the answer from that individual firsthand. So, after 15 minutes, if you are saying Oslo, thank you very much. But then, basically, is it necessary to remember all the countries' capital? No. Nobody is going to ask you about the capital of the countries, but ask yourself this particular question once, that you are, maybe you get selected for this examination, you will become selected for or you can be selected for Indian foreign services. Do you think government of India will have an individual being selected as Indian foreign services, an individual who doesn't know where the countries and the capitals are situated? It is not as if the countries and capitals will be asked. But what it tells also is that if this is not something you are very clear with, there will be many things associated. For example, if I ask you, where is Colombia? In which country is Colombia situated? In which continent, rather, is Colombia situated? Uh, Sri Lanka, Africa, Asia, Europe, North America. I am asking about Colombia. Colombo that you are writing as Sri Lanka is very different. See, that is what I'm trying to say. That this is a basic idea that you should have. That, for example, when you study Cartagena Protocol in Convention on Biological Diversity, Cartagena is in Colombia. Okay, in which continent is Cambodia situated? Africa. Okay, South America. Beautiful answers. So Colombia is in South America, Cambodia is in Asia. Okay. Yeah. Meanwhile, in a parallel universe, we still have some students typing very fast on Google, and the Google basically taking its time, and then now they are typing it, eventually giving the answer. But I hope you are getting the point that I'm trying to indicate here. You should be aware about this. This is high time in your life. You don't want to be an adult individual of 25, 30 years who tells somebody that I am preparing for civil services. They ask you, where is Colombia? And you will say that, no, no, this is not asked in civil services. They will press harder. No, tell me where Colombia is. It is the capital of Sri Lanka. So imagine, for your own sake, as a UPSC doesn't mention any much criteria for the candidates it selects, but it mentions this much: it needs an average aware graduate. Average and graduate is taken care of, but awareness part, right? So I am aware about many other things in life. Let UPSC ask me about where these celebrities are taking a holiday today. Let UPSC ask me about what is required in this particular food item. I have a lot of awareness. Awareness about the world around you. Awareness not about what the political parties are bickering against each other. What is the world and what is happening in the world around you? That awareness should be there. But anyways, it is up to you and up to your fine sense of judgment that whether USA is correct or not. For what is USA correct or not? What do you want to have as USA correct or not? USA is correct. For what? So if you are saying that basically Colombia is not in USA, my dear friend. Okay, right. District of Columbia you're talking about. I was asking about the country of Colombia. So yeah, anyways. So in the meanwhile, we have more knowledgeable people who basically are aware about the districts and the precincts in US. But basically, so in your, if you are aware to that level, where you can come up with the precincts and the flag, what is the flag of Virginia, Pennsylvania, and all of the districts and the states in US, well, then UPSC will be much less harder for you, so to say. But I hope you are getting the larger image here, larger point here. Anyways, coming back to the fjord. So fjords basically are these kinds of indented valley-like structures between the mountainous areas where you will find the seawater entering through in the valleys. Okay, so these are your fjords. So today what you can do is, first of all, open up a map, and in that map look at where Norway is. First of all, that will be a big task for many of you. So look where Norway is. It is, I will give you a hint also. It is situated in the northern portion of Europe. And there, look at the coastline. The coastline is not straight. The coastline is heavily indented. So all these are basically fjords. So observe all of these. Eventually, the ice would have melted now. In all these areas, the ice has melted, and these are your deep valley like depressions which are created, eventually emptying into the sea. So all of them, they empty into the sea. So Sushmit, your question basically, fjords, glacier finally sink into the sea. So all of this, yes, they basically melt into the or move into the portion of the sea nearby. Same feature you will observe in the northern extent of Canada also. In the southern part of New Zealand also. You will observe the feature and phenomena which is exactly similar. So a fjord is a long, deep, narrow body of water that reaches far inland. In fact, in Norway, you have the names of the various fjords also. You have a lot of mythology associated with these fjords also. It is, in fact, on the banks of these fjords. If you take a look at the region of Norway, observe basically the Scandinavian mountains. Scandinavian mountains. Now, almost the majority of the geographical area of Norway is mountainous, right? So it is not very habitable. The mountains in these higher latitudes, they're not very habitable. It is on the sides of these fjords that you will find majority of the settlements to be in existence, majority of the settlements to be in the habitable condition. So majority of the population in the Norway would region of Norway, even Sweden and Finland, they would be settled around one or the other of these fjords, basically. Okay. Now, after this, yes, the Vikings used these. That is correct. So after this, we come at the depositional features of the drumlins. So when we talk about the depositional features, one of them is the drumlin. Now, drumlins basically are almost in the shape of an inverted spoon. Now, here the drumlins that you observe, these are your drumlins. Observe these drumlins. Okay. I hope you are able to observe that this drumlin has got a kind of a streamlined shape associated. It has got a kind of a streamlined shape which is associated here. That is a drumlin. So here, this streamlined shape tells you that about the direction of the glacial flow also. If I ask you just by looking at this image and the shape, the direction of the glacial flow would be in this direction A, or would it be in opposite direction, that is B? What does the logic tell you? Where the glaciers would move? In which direction? A or B? A, always, right? So basically, what happens is as the glaciers they move, let's suppose, as the glaciers they move, okay, let's suppose these are the rocks. Now, when the glaciers move, they will deposit some materials. Now, these materials, over a period of time, here, if it has been deposited here slowly and steadily, so in this place, the ice movement, the speed of ice movement, will it be fast or will it be slow? It will be slower because of the obstruction created. So, as the movement is slower, there will be further greater amount of deposit. Slowly and steadily, more deposits will be created here. Okay. Eventually, the glacial movement will provide that kind of a streamlined shape. Generally, in a region, generally it is formed, the drumlins are created by the continental glaciers. In the case of a glacial movement, continental glacier movement, you will observe that many such drumlins, they are created at one go. Many such drumlins, they are created in one go. So obviously, a continental glacier would have been in existence. Alpine glaciers can never create the drumlins. Alpine glaciers, which is coming down the mountain, they can never create. But the continental ones, they can always create this. So that is when you have the creation of these drumlins. Okay. So this appears to look like a kind of a series of eggs kept in a slanting position. That is why the region where you will have a lot of these drumlins, they are also, this topography is what is also referred to as the basket of eggs topography. So this kind of topography is also what is known as basket of eggs topography. Okay, that is what is also known as the basket of eggs topography. So these are what your drumlins look like. So they are hills of sediment, generally quarter of a mile, that means almost 1 kilometer or more in length, and they have been streamlined by the glacial flow. They are oftentimes, that is why, elongated because of the glacial flow, right? Now they often occur together in fields, some with as many as several thousand individual such deposits. So that is basically the case of these drumlins. So that is how these depositional features are created. These drumlins are created by continental glaciers. Glaciers. So if they are created by continental glaciers, in which region of the world will they be observed to be in existence? Can we think about it? Yes, Devyani, correct. In the region around Antarctica, in the temperate area, in the region of higher latitudes, northwestern portion of Europe, very good. Greenland, very good. Northern Russia, very good. So basically, these will be continental glaciers where they have been in existence in the region around Greenland, Antarctica, northern Canada, and also the regions which have been impacted by ice age previously. That is where you find the existence of these continental glaciers. So continental glaciers, basically they move across a plain-like region. That is the continental glacier. So here what tends to happen, again I will repeat, listen to this carefully. Again, what happens is that as the glacial ice, let's suppose, is moving, right? Now it is moving in a plain area. Don't imagine the mountains now, because it is a continental glacier that we are talking about. So in the plain area, as they are moving, now they will be depositing these small chunks over a period of time. Multiple of these small chunks will be deposited. When the glacier, over a period of hundreds and thousands of years, the glacier melts and eventually disappears, you will have these chunks being left behind, and that is what is referred to as drumlins. So that is basically the case of drumlins in existence. In India also, in peninsular part of India, where you have the evidences of ancient glacial existence, there also you have had these drumlins. In many of the regions of Gondwana rocks, it is said that under those Gondwana rocks, you have had those ancient drumlins. Over them, obviously, lot of other deposits have also happened. Okay. Now, no, Kashmir is not where you have the continental glaciers. Kashmir is where you have alpine glaciers. Kashmir is not the region of continental glaciers. Continental glaciers you will only find in the very high latitudes. Okay. No, in Himalayas you will not observe them. Himalayas, again, you have alpine glaciers. You don't have continental glaciers. Then we have eskers. So eskers, just like drumlins, are deposits created by continental glaciers, but these deposits are straight, linear. Okay. When you have these straight and linear deposits, That is what is referred to as an esker. So eskers basically are the linear deposits created by the glacial meltwater, and as the glacier is moving, it starts depositing these in a linear manner. Now, if I ask you, these drumlins and eskers, will they be fertile or infertile? What does your logic tell you? Will they be fertile or infertile? Very good. They will be fertile because they are fine particle deposits, so they will always be very fertile. Now we come to the landforms which have been developed as a result of the wind action. Now, winds also have got a significant power to erode. Now, if they are eroding, they will also be able to carry the materials and eventually depositing it somewhere, right? So, gradation is carried out by the wind action also. So, here, when we talk about the landforms developed by wind, you have erosional landform, you have depositional landform. Now, obviously, these landforms will be much more prominent in those areas where the wind speed is very high. Only in those areas will the wind be able to erode, isn't it? Where the wind speed is substantially very high. So, when we talk about these landforms developed by wind, here found in areas of very high wind speed. Now, which are the regions of very high wind speed? You basically have arid and semi-arid areas, desert areas basically. Desert areas in general, where you have less obstruction, that is where these, what are known as the aeolian landforms, they will be very common. So basically, as the wind erodes from a region, you will observe certain phenomena. Let's suppose this is the ground surface. Let's suppose the wind blows in this area. Now, as the wind blows in this area, it will pick up the sand particles. Now, here also, the heavier of the sand particles. Now, in the desert, unlike what you see in the movies, where that all the sand appears to be very powdery, etc. Deserts, you have a mixture of very powdery sand, also very fine particle and large particle sand particles, large sized sand grains, which are also available. So when the wind blows, because of its weight, the lighter particles can be carried and lifted at a higher place. Okay. The lighter particles, they can be uplifted easily. But the heavier particles, obviously being heavier, they will be closer to the ground surface. So they are dragged very, very close to the ground surface. Okay. So these are your finer particles. These are your larger particles. Now, if you have a rock-like structure here, let's suppose. Now, these will hit the rock. Both finer and larger particles will hit the rock. Now, if I name this place as A, name this region of rock as A, and if I name this region of rock as B, where is it that the erosion or the chipping of the rock will be more predominant, A or B? Very good. Basically, where the larger particles will hit it, let's suppose this is the rock, larger particles will continue to hit it, so it will start chipping away the rock. The finer particles, when they hit them, they will keep on polishing the rock, they will rub against the rock surface. The lighter particles, they will rub against the rock surface, so they will polish the rock. So that is when they will develop beautiful patterns. But at the bottom, the rock will be hit by these larger particles slowly and steadily. It will be eroded. So that is why you will find that many of the rocks, they get thinner from the bottom. From all sides, as they are eroded, they get thinner from the bottom and they remain larger on top. This forms an erosional landform, what is also referred to as mushroom tables or mushroom rocks. Okay, this is what we refer to as mushroom rocks. So, how are mushroom rocks created? So, when we talk about mushroom rocks, these are very common. Even in Rajasthan, you will find them. These are also what are known as mushroom tables. In almost all the desertified areas, these are very common structures. So, what and how is it created? So, let's suppose this is the ground surface. Here you have an existing rock type, let's suppose. Now, as the wind is blowing, it is going to carry the larger particles closer to the ground surface because obviously of their weight, they will be heavy enough not to be carried too high in the air, and the finer particles will be moving at a particular height here. Now, as these heavier particles will continue to chip slowly and steadily, they will be shaving off the bottom here. Slowly, they will be shaving off the bottom here from all sides. That is how eventually you have that eroded structure getting created. Now, again, more erosion will happen. And then what do you have? You will come across such erosional structures like this. So here, because the shape appears to look like that of a mushroom, hence it is known as the mushroom rock or the mushroom table. So almost in all the desertified areas, Sahara Desert, Atacama Desert, then Thar Desert, Victoria Desert, Namib Desert, Kalahari Desert, almost in or Utah Desert, almost in all the various different deserts of the world, you will find these mushroom rocks. Now, after some time, what will happen? The winds will continue to blow. It is not as if once this mushroom rock has been created, the winds they will rest that now my purpose is done. Now I can die peacefully. The winds will continue to flow. So what will happen after this? The larger particles will continue to chip. So this rock eventually breaks from here. So after some time, you will come across a scenario where this rock, the earlier one, is broken and the newer one has fallen on the sides. Okay. Now, as this has fallen over a period of time, again, the same process will continue. So, what will happen? The size of this one will further reduce. This gets much smaller. And this one, again, from the bottom, it will get eroded. So, it again can create another mushroom structure. So, like that, very, very large rocks in the deserts over the period of hundreds and thousands of years, they get broken into many, many smaller portions. And that is how you have the what is referred when we said that the exogenic forces are levelers. That is how any protrusion on the landmass is leveled down. Okay. Now, in the deserts, you have another of these features, erosional features, which get created. And these are yardangs. Now, what are yardangs? So, yardangs, as you can see from the images, they also form a series of eroded rock structures. But where did these rocks come from? So, these rocks are basically the base rocks, the parent rocks. So on top of them, at one point of time, you would have had on top of them a lot of this sand, right? And alternate arrangement of hard and soft rock would have been present. Okay, so the softer rocks are eroded, the harder rocks are left behind, and that is how yardangs get created over a period of time. We will study about these yardangs in detail. We'll take a break and then we will be back. We will study about these yardangs and then eventually we'll finish up this portion and start with the portion of climatology today. So let's take a break and then we'll be back. So, apologies for the 40 minutes break. There were some pressing issues along with the health concern. So, yeah, I hope that you have had a good sojourn in between. I got to know in between, in the break, that many of you have not appeared for the test series. Is that the case? So basically, that was why it was elongated a bit. That many of you have not appeared for the test series. Kindly do appear for the test series, guys. Yes, Vishal, I know I have taken a look at the performance as well. I got an opportunity to browse through the performance of the individual candidates as well. And basically, not many of the performances are eye catching. So, what is the issue with regards to the prelims test series that you guys are facing? You can bring that to light. Didn't even clear cutoff. What cutoff? Questions are hard. Questions will be hard. Questions will always be hard. The purpose of the test series is to have a harder questions. No, no, don't think 90 marks is the cutoff. Okay. See, understand. I have seen the performance for many of you guys. The performance is not very pleasing for many of you. So understand that majority of the questions that have been asked, and in fact, I have had a detailed conversation in the break with both Abhishek sir, Sarmat sir, all of them, and the conclusion that we reached is that the basic questions are where many of you are committing errors. Okay. Are you talking about the weekend test? No, I'm talking about the prelims test series. The prelims test series, the first test was conducted this weekend. So that prelims test series. See, guys, understand. It is not going to be the case that the first test that you appear for, in the first test itself, you will be able to hit the ball out of the park. That is never the case. First few tests is something that will actually get you familiarized with the questions, the language of the question. The reason why the questions appear to be so very hard as of now is, first of all, we have deliberately, there was a detailed discussion about it earlier also, where uh, upon my insistence, you might hate me for that, upon my insistence, we basically insisted that the questions should not be very easy, because easier questions, they lower your own expectations, that this is the level to which I have to prepare. So what we have done is we have elevated the level of the questions deliberately in history, as per our directives. In history also, the questions which have been put, many of them are factual in nature, which might you might not have covered in the classes in detail. Try to inculcate that point into your knowledge set, into your knowledge arsenal. And as I always repeat, today also I repeat it, but with certain amount of disappointment and certain amount of worry, that see, regardless of whether you are appearing for the prelims this year, next year, year after that, whenever you are appearing for the prelims examination, take these test series as a point of learning, that whether your mind is conditioning itself in order to apply your mind for this duration of 2 hours, and understand that one way to solve the objective questions is to have that confidence that the answer is in front of you. You have to select the correct answer. It is not a rocket science. You would have read these. For example, I think this weekend you have the geography test, right? I think in this weekend you have the geography test, right? So the geography test that you are going to appear for, again, I will tell you, please don't get worried that I have not learned the names of the rivers and the tributaries, etc. Don't worry about it. For example, I would not be foolish enough to tell you the questions which are going to appear. For example, if you have a basic question about, let's suppose, the distribution of forest from one area of the country to the other, apply your logic there, that if the rainfall conditions are such in a certain area, what kind of forest would be found in that area? If I ask you from north to south, the arrangement of forest, you don't necessarily have to by heart it or rectify it, but you need to be basically be able to decipher that, for example, in Punjab, Haryana, there will be less rainfall, so thorny forest. In the southern part, more rainfall, so tropical evergreen or deciduous forest. So that application of logic has to happen from your side. Whenever you take up the prelims question or the test paper, analyze in first go. You should attack those questions which you are confident about. Then in the second go, attack those questions where you are partly certain, partly not very certain. In geography, if you have revised the PPTs, if you have been regular in the sessions, there is no way that the 50 basic questions should not be solved by you. Those 50 basic questions should be solved. Right now, if you are scoring in the range of 80 to 100, fair enough. If you are scoring less than that, that is where you need to, first of all, after the tests, when you get the solution, when you get the explanation, decipher it, try to examine it. That, for example, if let's suppose I'm deciphering it, so in in a particular area, if I have committed mistakes, why I have committed mistakes? Either I did not know it, or I knew it but was confused by the sentence, put it into another category. Or I knew the sentence, also I committed a silly mistake, means lapse of concentration, put it into another category. After every test, maintain your own data pointers, that how many errors are happening because of lack of concentration, because of lack of content, because of so and so. Only then will you go for self improvisation. And it is not a kind of a make or break, that if you are unable to push through in the present scenario, if you are unable to push through the 80s and 90s, it doesn't mean you won't get through the examination. I have seen endless number of cases where the candidates have been scoring very low in the test series, but they learned from each of the tests. They basically analyzed each of the weaker areas and they scored marvelously well in the actual prelims paper. So ensure that the learning happens, okay? And so that we don't have this conversation. I don't like this conversation quite often. So ensure that this conversation should not happen again, okay? The results will be shown for 24th test. The results will be published very shortly. So that is something that I have seen. I have taken a look at few of the performances. The expected names, they are performing nice, but I want the bulk of you to perform good. I won't be satisfied if 5 or 6 of you are performing nice. That doesn't give me that amount of pleasure here. So that is where I want the bulk of you to perform really good. Okay, right? What about the other subjects other than geography? Follow the same approach. The same approach. Basic questions are where the race is won or lost, not the factual questions, not the very hard questions. Very difficult questions are not something that you should be worried about. Nobody will be able to solve that. But the basic questions, you should not find it difficult to solve those basic questions. Okay? Srilata, you can attempt the test even now. How many questions should be correct out of 100? Don't take that approach. Ideally, even if you are sure of 45 questions, you will commit 3 to 4 errors there. But ideally, you should get 50 to 55 of them correct out of 100. So you have a scope to get 45 of them either you don't know or even incorrect. But 55 of them, you should get it correct. Okay? Right? Even those areas, for example, whichever portions you have completed, appear for the test only for that. There's no issue in that. but continue your studies. These tests are also a kind of a reminder how much hard work is required. Okay, it is on the basis of these tests that we have had good successes in the past. Today, this time also, after the end of the prelims examination, I can guarantee you we will have many of the candidates who will succeed in the prelims, many of the candidates who will succeed in the mains examination, because of the volume of candidates who are basically enrolled. We will have the successful list here also. It is not as if nobody will succeed. But do you find your name in that list or not? I hope you are not here just to make up the numbers. That is why, please do strive for it. Okay. I got 47 correct and 40 incorrect. So analyze the incorrect portions. Even the correct portions, there would be few of the boundary ones which you were not sure, but you got it correct. A chance factor. So there also analyze it. Okay. I hope I am able to convey this message clearly. Okay. I have scored 35 in prelims test 1, but my target is 2024. Kaushik, in that case, I would suggest that, again, the basic analysis. Why is it that mistakes are happening? That needs to be analyzed. Either you have not revised it properly, because in the same test, I'll tell you that few of the candidates are even scoring 130 plus, right? The candidates who have attempted the sessions along with you, few of them are getting even 120 plus, 125 plus easily. And these are the candidates who are amongst the expected list. So if the candidates are able to score that much with the same material, where is it that you are lacking? So that is where you have to understand. Leave 135, 120, 110, 100 at least you should be able to get. So how do you get that 100? So you get that 100 marks basically by minimizing those absolute tukkas, absolute guesswork, and understanding that the basic 45 to 50 questions out of those 100, it won't appear in bulk, it is distributed. You have to pick them out. Okay, right? Lekhani, there will be at least 20 questions which will be factual. 20 questions. I'm giving you that much scope. 20 questions factual. Let's assume you are not going to attempt that. 50 questions in geography. Let me assure you, I am basically crossing the bounds here. But let me assure you, 50 questions are the ones, if you apply yourself, spend some time in the question. And one other mistake that I am seeing with many of the candidates, immediately you are forming a conclusion by reading the first sentence itself that I know this question or I don't know this question. That should not be the case. Understand it, that whether that question which has been asked, what can I apply my, where can I apply my logic to? Many of us are used to that kind of a test format where we have read something from a book, we expect the same wordings at the end of the book, we'll get it correct. But that should not be the approach. So first things first, everybody appear for the test series. Do appear for the test series. Okay, without fail. Okay, and when you appear for the test series, let's suppose you are appearing for the examination 2 years down the line, this will set your mindset in order. Prelims, my dear friends, is a game of confidence. I One of the candidates who is right now posted in Mumbai in revenue services, that candidate, when he appeared for the prelims examination, he came back and said that I knew only 22 questions, but that person scored 130 plus in the prelims by pure application of logic, because you are reading current affairs also, you are reading multiple things in your life. Apply the logic. Those questions are meant for an average aware graduate. There's no reason why you shouldn't be able to solve them. Have that confidence within you. What will happen? Negative will happen. That is why you have these practice tests, so as to analyze. Okay, right? Now we continue. So Checha, that is what I am saying, that start applying yourself even now. Attempt for the test if you can, or if you are having your other exams right now, take a break. After this exams are over, take up this test series again, but don't wait that one fine day my preparation will be done and then I will appear for the test series. That time never comes in the life of a candidate. Never will you come across that time where the entire preparation is done and then you appear for the test series. That does not happen. Okay? Any doubts that you have, any fear that you have the contact of the mentorship line. You can get in touch with me. I'm there to help you guys. So I will help you guys. But when I see sincerity on the side of the candidates, that is when, as a faculty, also you want to help the candidates out. So that is something that will always drive me also to help you out. I hope this is taken in positivity. I hope that this is taken in due consideration. Okay, marks will demotivate. The once you clear the examination, will anybody ask you that what is the marks that you scored in the prelims? No, this is for your self evaluation, my dear friends. Okay, don't tell anybody what your marks are, as long as you are using them to improve yourself. Don't worry about the marks. That is why in the BHLP test also I tell you, even if you score 0, I don't care, as long as you are learning from each of these questions. I don't care if you score 0 in the BHLP tests on the weekends, but same approach in the prelims test series also. I don't care about the marks that you score. I'm not concerned if somebody is scoring 130 plus, does not mean that person will get through the prelims, does not mean that person will qualify easily. No. But if you are scoring less, analyze why is it, why can't I. One final advice that I will give you, one of my faculties had given me earlier, which helped me clear the examinations also. Basically, whenever I would always get demotivated, and we as the entire unit would get demotivated that I'm not able to understand these concepts, and when the faculty would explain them, we would be able to understand them easily. And he said that, understand this, if any of the concepts you are able to internalize, that means your mind is capable to think about them. If your mind is capable to think about them, there is no reason why you couldn't have come up with that solution on your own. That tells you the power of your own imagination about your own application. Many of the times what happens is we get belittled upon looking at the question paper, that we are not worthy enough, maybe this examination is not for me, maybe others would have read more. No, everybody has got more or less the same amount of preparation. It is at that point where how you perform, how your mind functions, control that. That is under your control. Your control is not over what kind of questions will be set. Nobody can control what kind of questions UPSC will throw at you next year. Maybe they will change the type of options that they give you, but then the controllable is, so in UPSC exam paper also you would see that the questions, they are dispersed in such a way, very hard, then in the entire page only very hard questions are there. Many of the candidates, they get so very stumped that 5 questions, 6 questions, I have no clue. Immediately they lose motivation, and the next easier question also they will commit mistake. It is where the mind is in order that you get that correct. So get that correct and you will be on your way. Okay, right. Now we come back to the topic. I hope that I'm not called to such meetings again. These meetings are not a very good thing. So basically, I hope that you guys take it in a positive manner, and I hope that when you attempt for the next couple of tests, you have a better performance. You should be satisfied. It is not about whether I am satisfied or not. You should be satisfied with your performance. Okay. Now coming with the portion of Yardangs. Um, I have just started. I don't know what to do, how to prepare. The basic portions should be read again and again and again and again, as many times as possible. The basic portion should be read. Now we come to the portion of Yardangs. So here in the Yardangs, you have the erosion of the base rocks. Erosion of base rocks. What do we mean by base rocks? So base rocks or the parent rock. So for example, let's suppose here you have sand, right? Then let's suppose you have the alternate arrangement of hard rocks, then softer rocks. And understand, guys, by the way, any of the times that you feel extremely demotivated, that whether this examination is there for me or not, always understand all that it takes to clear this examination is a good pinch of self confidence. Be confident in your ability, not overconfident or overtly arrogant, but confidence. That is more than sufficient. Now, these are your parent rocks. Let's suppose this is your hard rock. This is the soft rock. And they are arranged alternatively. Okay. Now, in this case, if the wind moves and as the wind blows with a substantial amount of speed and velocity, the top portion of the wind is carried, the top portion of the soil or the sand is going to be carried away, and these base rocks will then be exposed. So you will have a situation where the base rocks, due to erosion, will be exposed as the top layers are carried away. Okay. So there, as the top rocks or as the top soil is carried away, let's suppose now due to erosion, the soil layer has reached up till this portion. The sand layer has reached this portion. Now you have the exposed base rocks. Okay. Now these exposed base rocks, they will be subjected to erosion. Now, if I ask you amongst the hard rocks, the soft rocks, again the hard rocks against the soft rocks, which will be easier to erode? Will it be the hard rocks which will be easier to erode, or will it be the softer sedimentary rocks which will be easier to erode? Always the softer ones which will be easier to erode. So here, as the softer ones are eroded, you are left behind with the kind of a hard rock structure. They will also be eroded, but not to that extent. The soft rock is completely removed away. Again, you will have the hard rock, and the base of it will be completely eroded away. The soft rock will be eroded away. So the hard rocks will be left behind, but the soft rocks are completely eroded away. That leaves behind a kind of a corrugated structure which appears to look somewhat like this. So imagine at one point of time, you would have in between these areas the portion or the presence of softer rocks. So those portions of softer rocks would be present here. And those portions of softer rocks have been taken away, have been removed away. Okay, so that is basically how you have the formation of yardangs. Is that understood? Is that process understood about the formation of yardangs? It can happen like this only when the wind direction is the same, mostly, but also understand that generally the long-term wind pattern remains consistent. We come to climatology, we'll discuss about it. The long-term wind pattern remains consistent. Okay, right? Is that understood now? Hard rock will also be eroded, but not to the same extent. See, eventually, even these hard rocks will be hit at the bottom. Eventually, even they will weather down, they will also get eroded. But this yardang like structure, when it is created, it is when the softer rocks, they are completely removed out of the picture. That is about the formation and the existence of yardangs. Okay. Now, after this, we come to deflation hollows. What are deflation? Deflation, opposite of inflation, right? A depression which is created. Now, as I told you, in the desertified areas, you have a mixture of larger particles, smaller particles, finer particles, etc. All of them are present. So when you have basically the wind pattern, they will be able to pick up the fine particles. They will be able to pick up the fine particles. The larger particles will be left behind. So here, when the larger particles are left behind, the finer particles are carried away. That is when you have a kind of a deflation hollow. Okay. So in this case, the fine sand particles are carried away. Finer sand particles are carried by the wind. And the larger particles are left behind. This creates depression like structures known as deflation hollows. Okay, that creates depression like structures which we refer to as deflation hollows. So this is something which you observe in almost all the desert areas, including the Thar Desert, Victoria Desert, Sahara Desert, Atacama Desert. Wherever you have large deserts, basically it is not always the case that the particle size will be the same. Sometimes the particle size will be larger also, sometimes the particle size will be finer and smaller as well. So when the particle sizes, they are finer and smaller, they are easily carried by the wind because they are light in weight, and the larger particles will always be left behind. So that creates what is known as the deflation hollows. Okay. Now, after this, we come across dunes or sand dunes. Sand dunes are depositional structure. So as the wind basically transports these finer particles, it will deposit them somewhere, it will drop them somewhere. So they are deposited in the form of mounds, which we refer to as dunes. So these are basically depositional mounds created by the particles carried by the wind. Now, depending upon the direction of the wind, the pattern of the wind movement, the deposition will also be in the same manner, right? For example, let's suppose you have the wind coming, converging from both directions. Let's suppose winds converge from both directions. So all those deposits will be there in a central mound. All those deposits will be there in the central mound. Right. So that kind of a deposit in the central mound which will get created, that is what is referred to as a longitudinal dune. Sometimes it can also happen that as the wind blows in a certain manner, it will deposit dunes parallel to each other. These are your transverse dunes. Okay, they appear like series of parallel dunes. Historically, these transverse dunes, they have been used by the travelers and the merchants and the traders also. They would basically take the shelter of these dunes as they would move in order to escape from the dust storms. Now, if I ask you a basic questions, that will these dunes be permanent structure or will these dunes be shifting in nature? What do you think? Very good. They will be shifting. They will be temporary structures. They will shift from one region to another. Because of the movement of the wind, they can easily shift from one area to another. They can be transported, carried over from one region to another, isn't it? So that is basically why as the wind picks up or slows down, as the wind pattern changes, many of the time, slowly and steadily, these dunes from the top they will be picked up slowly and steadily. The entire dune structure in itself can be plucked over and can be dumped in another area. So that is how you have the deposition of the dunes. Okay, if rain comes after, desert areas are not very prone to lot of rainfall. That is, desert areas are the regions where rainfall will be almost minimal, so the rainfall is not an impactful factor for the creation of these dunes. Okay, no, it does not take millions of years to form the dunes. In few thousand years they will be formed, or hundreds of years also. Yes, the longitudinal dunes are also parallel to each other. Okay, now this is basically the shape of the dune. The shape of the dune. Now, sometimes what can happen is, let's suppose there is a dune. There is a larger dune-like structure which gets created. Let's suppose there is a larger dune-like structure created. This one. It can happen that the central portion in itself slips and falls over. The central portion in itself slips and falls over. So as the central portion slips and falls over, what do you have? You basically have the creation of a crescent shaped dune, what are known as barchans. So when we talk about barchans, so barchans are basically when you have a larger dune like structure. Okay, yeah. And the central portion in itself, this central portion, as you can see, that has slipped over. So then you have the creation of a kind of what you refer to as a barchan, where observe at one point of time, you can imagine that this entire region would have been a dune. But due to the weight, and it is all loose sand after all, it is nothing but loose sand which compacts itself over a period of time. So here the central portion can also slip away. So that is where As the central portion, due to the weight imposed, the central portion slips away. It creates a crescent-shaped dune. Shaped dune. And that is what we refer to as Barchan. Okay, so Barchans will always have a kind of a shape somewhat like this. Always. They will have two protruding portions because the central portion has slipped over. So that is why the protruding portions are left behind. So that is where the Barchans will be left behind. Okay? Yes, Vikal. They are always curvilinear. Can we find sandstone in these areas due to heavy pressure? Yes. I will tell you what kind of questions will be asked. I will give you a kind of a prelims question which can be asked from here. Now, this time, for example, in the mains examination, you had a question, direct question about fjords. What are fjords? So you can have that kind of a direct question asked in the mains examination also. About any of these features, you can have a direct question being asked in the examination. Okay. Then we come to the landform developed by waves. So what are the landforms developed due to the wave action? So basically, when we talk about the landforms developed by waves, you have the erosional landform, you have the depositional landform. Now, erosional landform is the one, basically, the sea waves, when they crash against the rocks, they have a significant amount of a power associated. They bring some amount of sediments also, and they deposit it in the coastal area. That is how you find the presence of very good beaches, right? So the sea waves, they also have got immense power. And also understand that the action of the sea waves is both chemical as well as physical in nature. Sea waves, being salty in nature, tends to dissolve certain materials, right? That tends to dissolve certain amount of materials. That tends to pluck out and take out certain amount of materials. So the sea waves, they will continue to dissolve certain amount of materials, and plus the physical force of the water, physical force of the wave, that will also create an impact. So here you have both erosional as well as depositional landform. We'll start with one of them, starting with cliffs, the sea cliffs. Cliff is a name associated for any place where you have a significant amount of a height associated and a sudden fall associated with it. So this is what a cliff appears to look like. By the way, just to inform you guys, this Saturday we are going to have an extra class. Okay, for the class that we cancelled on Friday, this Saturday we are going to have an extra session. I hope you are comfortable with that. I hope you don't have many engagements. You can push your cabinet meetings and other ministerial meetings that you guys have. So this Saturday we will have the extra session in the morning, and we will try to keep it comfortable for you guys. So I'm trying to keep the session at around 7:30, and till the time that you are comfortable, I will continue. Ideally, I can continue for 4 5 hours, but I don't want you to get oversaturated. So I will have it on from 7:30 to 11:30 or 12. I will give you breaks in between as well. Okay, so it is not in the evening, it will be in the morning around 7:30. In the morning we will keep the extra session. So all the cabinet meetings, minister meetings, all of that you have, kindly push it for one day. Take it on the I understand many of you have international commitments also. Push it for one day, and then I hope you can take some time out for the subject. Okay, in that case, Checha, don't worry. You can take a look at the recordings, but do take a look at the recordings before Monday, because we will be dealing with climatology, and climatology is one of those areas where we will be building one concept upon another. So don't let any of those portions get missed out. Otherwise, you will feel out of place. Classes are there. Which classes are there? I have a paper on Saturday. Fair enough. After you appear for the paper, take a look at the recordings. Okay, college classes are there. Fair enough. You might have some other pressing commitments. Take a look at the recordings in those cases, but do take a look at the recordings before you come for the Monday's class. That will be my only request. Okay, right? No, climatology will start today itself. Okay, Ankit, please tell me the way to speak English fluently. Okay, so you want to improve your spoken English. See, I'm not particularly well versed in the language myself. I also am in a learning phase. So it would be absolutely incorrect for me to start handing out suggestions. I can hand you out suggestions for geography if you want, but English is certainly not one of my stronger points here. But nonetheless, practice, read more. For example, that is something that I have a habit of. I read at least one book on a daily basis. So do read that. In geography schedule, no classes on Monday. Okay, Monday is first of January. I think it is a holiday. Fair enough. So you get time to revise that on Monday. Tuesday, before Tuesday evening class, revise that and come to the class. Okay, right? So, Ankit, before ending it, I'll just tell you: the more you read, the better you are at expressing yourself. It is just a language, my dear friend. And if you are fluent in your mother tongue, you can be fluent in any other language. It is just that you have to know when to say what and how to express yourself. After all, that is what it is. It is a language of communication. Okay. Anyways, so coming back to the portion of cliffs. So when we talk about these cliffs, these are some of the most picturesque things that and visually appealing things that you will come across in the coastal areas. It is not across the world that you will come across these sea cliffs. For example, in India, I hope you have heard the name of Varkala in Kerala. Beautiful place. Those of you from Kerala would vouch for it. Those of you who basically would have visited Kerala would have also seen this. Those of you who have not, look at the images there. Now, Varkala is known for some of the most beautiful and picturesque cliffs. There it is the sandstone cliffs, but you also have limestone cliffs. For example, in the region of the Scottish Highlands, for example, the image that you see here is that of the Scottish Highlands. There you have these limestone cliffs. Now, these cliffs, they are not formed at one go. They are formed in recurrent processes. Okay, they are formed in many of these recurrent phases. Okay, so how is it formed? Let us understand and get a step by step clear image about it. So for anything in geography, again I would stress, particularly in geomorphology, think about what would have been there in the past. And that is the beauty of the subject. If you know what would have been there in the past, if you know the present process, you can predict the future also. This was one of the very famous theories given by Thornbury. And basically, he said that if you are able to look at the past, if you are able to know the process at present, you will be able to predict what the future land forms will appear to look like. So here, anyways, you don't have to remember the name Thornbury, unless and until you are preparing for optional. You don't have to go through this. But how is it that these sea cliffs are created? Here, when you talk about the past, one point of time in the geological history of this place, you would have the region somewhat like this. Somewhat like this. Okay. Now, the sea waves with their power, they would hit the base. They would always basically hit the bottom. So, as they would hit the base, what would happen is they would erode the base. I actually got a very nice comment about one of the other candidates is offering you that they will help you learn English fluently, but he's charging a fees. So I'll tell you free of cost, don't ever pay money for improvement of English. Okay, that is a free advice I will give you. Don't ever pay money to learn how to speak English. Save money in that regards. Nonetheless, so here basically you will have the power of the sea waves. They will be basically hit the bottom. They will continue to hit the bottom, and they will continue to erode even this area. They will continue to erode even this area. Now, as they continue to erode it, you will come across a scenario or a situation where it will appear to look like a kind of a structure like this. Okay, here. So here you observe an overhanging structure. Now, think about it. Will this overhanging structure be stable, or will this overhanging structure be unstable? Think about it. Obviously, it will be unstable, isn't it? This is what is also referred to as a notch. This is what is also referred to as a notch. Now, this overhanging portion of a notch will be exposed to rainfall, sunlight, sunshine, heating, and the salty water of the sea also will carry out some chemical weathering of the region, will carry out certain chemical dissolutions of the materials to be found in that area. It will start dissolving the material slowly and steadily. Eventually, what will happen? Eventually, you will have this entirety of the portion breaking off, right? It will fall into the sea. So, when it falls into the sea, what kind of structure will be left over? You will have a vertical structure. But the sea wave will continue its action. So, sea wave, as it continues its action, even this portion will be eroded ever so slight here also. So, you will have a structure like this again, having like this. Right. So, after this, you observe that there is again another existence of a notch. This is also a notch, but this will also be unstable. So, what will be created? Eventually, even this portion will be broken off. When that portion is also broken off, again, you will have a vertical wall-like formation. So, this process will continue to happen. And that is how the sea cliffs, they keep on receding. Earlier, they might be present in this region. The sea might be present here. Right. Let's suppose the cliff is here. The sea is present up till here. Now, let's suppose the cliff reaches here, the sea will reach here. Let's suppose the cliff reaches here, the sea will reach here. So, like that, it is always going to be in a kind of a recessionary fashion. So, that is basically the case of sea cliffs, mostly formed in sedimentary rock formations. Mostly formed in the sedimentary rock formations. Eventually, hundreds and thousands of years later, they will disappear. Why? Because exogenic forces are the greatest levelers, right? They will level everything to the ground. At one point of time in the ancient Pangaea, Pangaea was a desert almost. The entirety of the region in the interior of the Pangaea was almost a desert. It was only the sides of Pangaea which had these mountains and the mountainous formation. So you had a lot of these cliffs. Many of them were raised to the ground. Many of them were flattened. Right? So that is basically how these structures they get created. Okay. Now, a couple of depositional features. When we talk about depositional features, the sea, think about it. Let's suppose it has eroded materials from here. These materials have been eroded in the formation of the cliff. Just an example I am giving you. The seawater will have these. Maybe the sea waves and the ocean currents carry that water. That water will bring the sediments here, will deposit the sand particles here, form a beach. So like that, the sea also has got multiple huge amount of sand or the sedimentary load, and it continues to deposit there. Now, the shape and the pattern in which it is deposited, that is where the name is also given to. Various different names are accrued to it. For example, let's suppose here, if you have a coastal area, let's suppose this is the coastal area. Now, coastal area is never going to be very straight, highly indented, of varying shapes. Let's suppose this is your land and this is your sea. Now, in the areas, this is the top view. Let me give you the cross-sectional view or the side view also. Let's suppose this is the land here. This is the side view I'm giving you of water. Okay, this is your sea. Now, sometimes what can happen is that this sea will start depositing sand here. It will appear almost parallel to the coastline. Not joined to the coastline, but parallel to the coastline. These are your sand deposits. These kind of parallel deposits, they are known. They come above water. You will find a lot of these kind of sand deposits in the region of Kerala coastline, particularly around Thiruvananthapuram, Kovalam area. You'll find a lot of them, even in the region around Alleppey. So this is basically what is known as a sand bar. Okay. Now, sometimes it can also happen that, let's suppose, the sea is trying to deposit sediments here or sand here, but there is a strong influence of a wind, direction of the wind. This is your wind movement. Okay, let's suppose there's a very strong wind movement. Now, this wind movement, as it happens, this wind movement will impact how it is deposited. Most of the deposits will happen in the direction of the wind. So that is when you have these series of deposits which are attached to the mainland, which are attached to the coastal area, but their direction is bit, in a way, it is elongated. So that is what we refer to as spits. Such kinds of deposits, they are known as spits. I will show you the image also. So here, if you observe these deposits in this region. From one point or at one angle, it is joined from the mainland. But then it extends and is connected by the mainland. So that kind of deposit basically is the case of a spit. This is your spit. So spits are the deposits which are attached to the mainland, but the direction of the deposit, their orientation, their alignment is influenced by the direction of the wind. Okay, wind many of the times it blows parallel to the coastline, so that is when it happens almost parallel to the coastline. This kind of a wind is also known by the name of longshore winds, but you don't have to go into the details of that. Again, something restricted for the optional area. So that is what you have, and that is the portion which we refer to as the existence and the formation of spits. Okay, now sometimes in the region of the coastal area, you will also find small islands which are not attached to the mainland. Small islands which are not attached to the mainland. Okay. Now, the movement of water in this area, will it be fast or slow? Movement of water in this area, will it be fast or slow? In this region here, that will be slow. Movement of water will be fast here, it will be fast here, it will be fast here, it will be fast here, but by the time that the water comes here, the movement will be very slow. So that is where the water will start depositing the sediments, and the water deposits the sand which connects this island to the mainland. So these deposits which connect the island to the mainland, these are what are known as tombolos. Okay, this island now becomes tied to the mainland. It is no longer an island, it becomes tied to the mainland. So this becomes what is known as a tied island. How you tie something with a rope or a knot to a particular base, a particular platform, that is how it is named as a tied island. Okay, so that is basically how these tombolos get created. So for example, observe this particular portion at one point of time would be separated from the mainland. This would be a kind of an island like structure. Okay, now over a period of time there would be deposits here, there would be deposits here also, right? So this in a way becomes a tombolo. Okay, many of the times in the case of a high tide, this will get water will come over it, but in general this is where you will have a lot of these deposits coming into existence, coming into feature. So that is basically the case of spits and tombolos. So we have seen cliffs, we have seen bars, we have seen spits, we have seen tombolos, we have seen the case of Tide Island. Now, here, the erosional features, some of the erosional features. So, as I told you, that basically can't understand the difference between spits and tombolos. Okay, very simple. If let's suppose, if let's suppose this is a feature, yeah, a land feature, let's suppose this is your land. This is a small island. If deposits happen which connects the land to this island, that is a tombolo. If let's say the deposits happen like this, almost parallel to the coastline but attached to the coastline, this is a spit. Is that understood? Now, is that understood now? Yes? Okay. If India connects with Australia, will it become a tombolo? See, if India connects with Australia, it will be much more than a tombolo. It will be one of the larger continents that you are talking about. So I understand the power of imagination, but this is too much to imagine even for me. So basically, when you have the region which is separated by tens of thousands of kilometers, fair enough, if you can think about that scenario. So if let's suppose when you talk about if that means you might not have visited many of the coastal areas. So many of the coastal areas, for example, see, I'm not going to comment on Ram Setu. So please don't ask me to comment on Ram Setu. Okay, whether Ram Setu is a tombolo, whether Ram Setu is a landmass, whether Ram Setu, whatever it is, I'm not going to comment on that. Even if you put a gun to my head, I refrain from commenting on these critical issues. So, on a private discussion, we can have a discussion about how these got created, but not here. So, basically, when we talk about these tambolos, so whenever you visit a coastal area, let's suppose here, wait for some time, let me do this one, and then I will help you with the example. So the sea waves, when they hit the coastal rocks, many of the times they will, in a way, erode the coastal rocks in such a way that cave like structures get created. Okay, cave like structures, they get created. Now, these cave like structures, let's suppose they are joined from the other side also. So, water can move through and through. So, you will be able to look at a structure somewhat like this, where you have a kind of an arch, right, with an overhanging roof and the base fixed on both sides. Now, if I ask you if this roof is going to be stable or unstable, what do you think? Ankush, from that point of view, yes. Will that roof be stable or unstable? Unstable, always unstable because it is overhanging, it is exposed to sun, heating, cooling, everything. So over a period of time, this roof might collapse. So as the roof collapses, you are left with a kind of an individual standing platform, and that is what is known as a stack. Over a period of time, even this stack will get eroded. Right? Even the top portion of the stack might get eroded. As the top portion of the stack gets eroded, you are left with a reduced form, what is known as a stump. Weathering and erosion are also exogenic forces. Exogenic forces are the greatest levelers. They will level everything to the ground surface. So that is when that stack gets eroded to form a kind of a stump. So that is basically how you have these erosional structures. Now let's suppose, coming back to the issue of these pits and tombolos, let's suppose you have one such stump which is here. Now the deposition by sea over a period of time might connect these together. It is not dangerous to walk over them. It is not as if it is very dangerous to walk over them, but in the cases of sudden storm surge or rise in sea level, that region will obviously get drowned over. So that is basically the case of a tombolo. This is a tombolo. Okay. Its height, how would it be shortened? Due to weathering. Height will be shortened due to continuous process of weathering, where the top portion is getting weathered down. Okay. Period of time they would. Now, this is a kind of a question which will be framed. That is, cirques, arêtes, horns, and drumlins represent which type of topography? Very simple one. I expect all of you to give the correct answer, but obviously that is not going to happen. So at least 90% of you give that correctly. Cirques, arêtes, horns, and drumlins represent which topography? Riverine, groundwater, glacial, coastal. No, Isha. Stumps can never be converted back into arches. 74%. Good. So these are your glacial landforms which get created. The rest of the questions we have already taken. Sandbars sprayed. Now, sandbars are when, let's suppose you have the coastal area, and in cases of shallow water depth, if you have deposits which occur parallel to the coastline but are not connected to the coastline per se, these are what are known as bars. Right? Even you have basically the in restaurants also you have the bar counters. They have a kind of a parallel linear existence or construction. So that is where the name has been derived from. So these are what are known as bars. Is that understood now? Okay. Okay. So now we move forward to the portion of climatology. I will give you the brief intro about climatology today. I will not tell you, I will not take you to the greater depths of climatology today, but a brief intro about it. Climatology, one question, there is no point of a leaderboard here. We'll talk about the wind movement, Sushmit. Now is where we come to the wind movement. Okay, let's do one thing. Let's talk about few of the subjective questions. Let me talk about few of the subjective questions. This is the leaderboard. Cedric, as always, is there. The kind of creative names that you put, it is as if I'm taking part in a kind of a gaming platform. So, Golden Crow and all the kind of creative names. Very nice. Anyways, so here, explain the formation of thousands of islands in Indonesian and Philippines archipelago. This is a PYQ. So, how would you basically account for the formation of these islands? What is the reason behind the formation of islands in the Indonesian and Philippines archipelago? We have discussed this. Could you please let me know? Just a couple of words would be sufficient. How these islands get created? Kindly elaborate. Brajneet. Krishika, good. Oceanic convergence. Yes. So, in the region of Indonesian and Philippines archipelago, what we observe is a convergence of plates. Convergence. And which kind of convergence? Oceanic convergence. Oceanic convergence would be observed. Now, if oceanic convergence is observed, means what? It basically means that there will be volcanic eruption. So in this answer, you have to talk about that, for example, the intro you have to give that the Indonesian and the Philippine archipelago is dotted with thousands of islands. Most of them are volcanic in origin. The formation of these islands can be ably explained with the help of the tectonic plate movements. That's it. That's your brief introduction. After that, you draw the schematic images. Archipelago is the name given to a group of islands. Draw the image of the plate movement. Explain why that is happening. Explain the formation of a trench also, oceanic trench also. Melting beyond the depth, water will also melt. If water will also vaporize, rather, it will give rise to volcanic eruption. This volcanic eruption, as long as the plate continues to move, the volcanic eruption will continue to happen. Eventually, you will have the formation of these islands. Now, in the entire zone where there is a plate movement, where there is a convergence, at the entire plate boundary, you will have a series of these island formations giving rise to island arcs. So that is how island arcs they get created. Okay, series of islands or island arcs get created. Will you be able to write the answer out of it? I hope no difficulty will be faced. Good. This is 150 words. 10 marks, 150 words. As of now, it is important to write. Write your heart out. Whatever is there inside, pour it out. It is important for you to express. Okay? Girish, I told you the introduction that the Indonesian and the Philippine archipelago are dotted with numerous islands, many of them being volcanic in origin. The formation of these islands can be ably explained with the help of the tectonic plate movements. That's it. Right? After that, these tectonic plate movements in the region of Indonesia and the Philippine Islands represent an oceanic convergence, where you have the convergence of the Pacific plate as well as the Caroline Sea plate, along with the presence of the Philippine Sea plate. On the Indonesian side, you have the convergence of the oceanic crust of the Indian plate movement. Just talk about this, draw the schematic diagram, explain it, talk about it, that how this leads to the creation of a series of islands, oceanic trenches. These are the regions of active seismicity, etc. It will be sufficient. Now, why are the world's fold mountain systems located along the margins of continents? Bring out the association between the global distribution of fold mountains and the earthquakes and volcanoes. So, fold mountain systems, why are they located across the margins of the continents? Because of oceanic continental convergence, right? Example, Rockies, Andes, Atlas, right? These are the examples that you give. Even, for example, you can give the case of the Ural and the Caucasus. They also are at the margins of the continents, right? In most of the cases. Now, the second part of the question is the global distribution of fold mountains and earthquakes and volcanoes. Now, in the global distribution, you also have to talk about Alps and Himalayas. They are also fold mountains, but their volcanic eruption will not happen. There only earthquakes will happen. But in the region around the Rockies, in the region around the Andes, you will have volcanic eruption also. So there you have to talk about where you have the oceanic convergence. Oceanic convergence will bring out both earthquakes and volcanoes. Only continental convergences, continental convergence, they will bring out only the formation of fold mountains. Okay? Yes, Krishika. Then mantle plume and its role in plate tectonics. We have discussed this. I had put it in the subjective test for the weekend also. Characteristics and the types of primary rocks. Can we discuss? Can we write the answer about the primary rocks? Primary rocks here refer to the igneous rocks. Characteristics, they are hard. They are formed by the solidification of magma. They base or lava. They are extrusive, intrusive. Grain size differs. Then basically they have a categorization into mafic, ultramafic, and felsic. Now mafic will have, I have given you the characteristic of the density also. So talk about all of them in detail. It will basically be more than sufficient. Discuss the geophysical characteristic of the circum-Pacific zone. So circum-Pacific zone, that is the Pacific Ring of Fire. This is a question UPSC has repeated, I don't know how many times. So there, talk about the oceanic convergence which happens in different areas. All these oceanic convergences, oceanic continental or oceanic, they will give rise to the occurrence of earthquakes, volcanoes, formation of fold mountains, formation of oceanic trenches. All of them you have to discuss here. How are the fjords formed? We have discussed. Why do they constitute some of the most picturesque areas of the world? Because they form deep valleys where the seawater enters in, the seawater gets into that area. We will come to the portion of oceanography. We'll discuss even about the corals. So the corals are also to be found in those areas. So this is about the glacial erosion. Okay, right? In the characteristic type question, what I write in the conclusion. See, in this particular characteristic of the primary rocks, in the conclusion part, simply concentrate on the primary rocks. For example, these are the rocks which eventually, when eroded, can lead to formation of the sedimentary rocks, or can even under application of pressure and temperature can get converted into metamorphic rocks also. So these rocks form the base for the prime conversion into other kind of rocks as per the rock cycle. That is why our understanding of the primary rocks becomes very important. That's it. Okay. So that is where we'll restrict the session here today. We meet again tomorrow, where we continue with the portion of climatology. From tomorrow, kindly be as regular as you can, because from tomorrow we will be building upon the concepts one by one, and we will be moving ahead. Take care of yourself. Thank you for the patience. See you again tomorrow. Take rest. Goodbye. Have a good night. Tomorrow, Lakshmi.